So when we're dealing with cost analysis, we're looking at the behavior that firms have relating to aspects of production. And we know that all firms that produce will have to incur certain costs. So we're going to break up these costs into what are called accounting costs, opportunity costs, fixed and variable costs, and direct costs that are related with a firm. So what are accounting costs? Whenever we're dealing with accounting costs, we're dealing with costs which are incurred and recorded in the books of accounting by a firm. So these costs include costs like wages, rent, buildings, the prices of raw materials, fuel, and power. They are also called explicit costs. So you need to understand what accounting costs are and what economic costs are. So when we add an implicit costs to the accounting costs, they make what we call economic costs. So the economic costs usually include a normal return on money or on capital invested by an entrepreneur himself. So we'll be dealing with the cost theory in terms of curves, in terms of the definitions, in terms of opportunity cost. Now, we've been talking about this key concept of opportunity cost, even in your assignments. In your own term, what do you think opportunity cost is? What is opportunity cost? How do you understand opportunity cost? Most people would say simply a benefit forgone that you could have derived from an option not taken advantage of. So the concept of opportunity cost is very important in economics because it brings about issues of a trade-off, issues of the value that we are willing to forgo for one choice made over the other. So in short, whenever we're dealing with opportunity cost, we're actually looking at the value of what you're losing when choosing between two available options. In an event where you decide to choose what you have now in the face of what you're yet to lose. So the concept of opportunity cost is really important. We are going to look at calculations to do with that later on. Direct cost and indirect costs. Whenever we're dealing with direct costs, we're dealing with costs that are directly related or identified or that are traceable to a particular product in an organization. For instance, in a factory like Zambia Sugar, the direct costs that are pertaining to manufacturing would be the factory overheads, the direct costs, the direct material costs that are involved in producing sugar. Indirect costs may not directly be traced to a particular product per se, but are also associated, they have a relationship to the ultimate product itself. You may have Zambia Sugar, for instance, which may incur costs like salaries to a gatekeeper. You know, Zambia Sugar also has clinics, salaries to nurses. The nurses are not directly related to production, but they're there to make sure that the workers are in shape. The health of production manager is in shape. So the cost of paying the clinics is associated to an indirect cost. Then we come to what are called fixed and variable costs. And fixed cost, this is a fixed expenditure of funds that is irrespective of the level of output. So graphically, when we're dealing with fixed costs, we're dealing with costs that don't vary with production. So you have a curve like this. This would be a fixed cost. So we have our output, our total cost here, fixed cost here. So when you're dealing with the cost theory, the total costs comprises of two important components. There's a fixed part of the cost, which is called the fixed cost, and there's a variable component, which is called the variable cost. So if you're dealing with an equation, the total cost given by 10 plus 2q, which one is our fixed cost and which one is our variable cost? The 10 is a fixed cost, it's a constant. The 2q is our variable cost. It varies with output. Now, those of you who have done mini calculus will understand that cost theory is a little bit diverse. So I'll talk about 5 key formulas that you need to know and how we can tabulate this. So when you're dealing with the total fixed cost, we have the following function. The total cost is equal to total fixed cost plus the total variable cost. When we divide the total cost over quantity, we call this our what? Our average total cost, ATC. Anything divided by Q becomes average. Are you together? So what becomes our total fixed cost if we divide it by Q?
Average fixed cost.
It becomes our average fixed cost. And what becomes our total variable cost divided by quantity?
Average variable cost.
Becomes average variable cost. So we need to understand the cost behavior that firms undergo, especially when we begin discussing the market structures. There's a cost implication and there's a cost behavior that firms undergo. So when we differentiate, when we find the change in the total cost with respect to quantity, what do we call that? Our change in total cost with respect to the change in quantity, we call this what? Our marginal cost. So marginal is anything additional. Together. So marginal cost is simply the change in the total cost over the change in quantity. If we use calculus, it will be DTC over dQ. This will be called our marginal cost. If we're given a function like this, our total cost is given by 40 plus 50Q plus 5Q squared. So I want somebody here to identify my fixed cost, and you're given the value of Q, maybe is 10 units. Okay, so what becomes our total fixed cost from here, from what we discussed so far? What is our fixed cost here?
Our fixed cost is 40.
Our fixed cost becomes 40. And what becomes our average fixed cost?
Score.
P over Q over 10.
Total fixed cost over the quantity. So the 40 divided by the 10, which gives us a 4, correct? So the value of the total of the average fixed cost becomes our 4. Then what becomes our total variable cost? What is the function of the total variable cost? We said variable cost is simply the aspect of the cost that is dependent on output. In layman's language, is simply the part that has a letter. So here, what becomes our variable?
5. It's 50Q.
The Q plus what? 5Q squared. This whole function is variable. It's dependent. Once we alter output by any unit, it will alter the ultimate total cost. Okay, so we're going to understand later on why our cost functions are U-shaped. So what becomes our average variable cost? The function will be the total variable cost over what? So in this case, we're going to get 50 over Q, 50Q over Q, which is 50, plus 5Q squared over Q will give us a what? A 5Q. Are we together on how we're finding this?
No.
If you can explain.
Okay, so we said anything average is anything divided by quantity. So the total variable cost, we have our total fixed cost, which is 50Q plus 5Q squared. And we're going to divide by Q. So this Q is going to divide in everything, not once. Most people want to make mathematical errors. When you divide here, it disappears. You divide them separate. So this will be what? 50 plus 5Q. Is that clear? Then now we can substitute our value of Q, which is a 10. So when we put our 10 there, our average variable cost will be what? 100.
Where has the squared gone?
Where has the square gone? Is the question there?
When you cancel the Q down there and the other Q is equal to 1, 2 remains.
I thought we were cancelling the other Q with the other one, which is on the 5th side.
Okay, so like I said, mathematical errors, ideally, you're supposed to split the Q like that, so that you don't avoid that mistake. I think I mentioned that because if you're going to cancel this, it will disappear. So you need to do it individually. This and that, we have our 50 there. This and that, we have our 5Q there. Is that clear?
Yes, yes.
All right. So this is how we find our 50 plus 5Q. So this is how we find our average variable cost. Now, the cost function has an autonomous point. Now this point here is simply a point where firms will ultimately have to undergo or bear a certain cost even with their production. So the costs that we're going to bear even if we're not producing anything. For instance, if you have a shop in town that you're renting, there are certain costs no matter what that you're going to incur. Those autonomous costs are actually called fixed costs. If you bring in the aspect of revenue, the revenue function looks like this. So whenever the total revenue is more than our total cost, there's a new term that we will introduce. What is that term? Whenever our revenues exceed our total costs, what do we call that?
Profit.
So we have point A, point B. Can somebody tell me which point denotes the profits? X, Y, and Z. At which point are we making more revenues than our costs?
Y.
At Y. So at Y, the profit is being made because the total revenue here is exceeding our total cost here. At the point where the total revenue and the total cost meet has a special term. Can somebody remind us what point do we call the point where the total revenue meets the total cost curve?
Break even.
Break-even point. So, you'll be having a quiz very soon. So quizzes are very tricky, or tests are very tricky that come with multiple choice. So you just need to understand principles. So if you're going to advise a firm to produce, at which points are you going to advise them to produce? Between 0, 2, 3, and 5.
Between 2 and 3?
Between 2 and 3, the firm is making a profit. But what is happening at X and Z?
They're making losses.
The
So at X and Z, you see that the total costs or the overheads are exceeding the revenues. So whenever total revenue is less than the total cost, we call that a loss, or our profit is in its negative. The point at A and B is a point where the total costs and the total revenues meet. So at that point, we call them the break-even points. Break-even point is simply a point where our profits are equal to 0. So at point A and point B, our firms are what? Are at break-even point. So between points A and B, that's where the firm will be enjoying its profits. However, within these points A and B, there's a point at which our total revenue is maximized. So we're going to now look at the revenue function. So the revenues, whenever we're dealing with revenues, we're looking at what? Sales. Okay. So total revenue is given by what function? Those of you who've been in my class by now, at least you must be familiar with all this. How do we find the total revenue?
Price by quantity.
Good, the price divided by quantity. When we said anything divided by quantity, the term changes. So when you divide our total revenue by quantity, what do we call this?
Average total revenue.
The T just becomes an A, our average revenue. And the change in total revenue divided by the change in quantity. What do we call that?
Marginal revenue.
Called the marginal revenue. Good. So if you're using calculus, it is the Q, the TR over what? The Q. So whenever anything marginal is equated to 0, we are either maximizing or minimizing. The general term is what we call optimization. So by definition, to optimize, to find the best quantity, the best output, best price that will give you the highest possible function. So optimization is part of the definition of managerial economics. Can somebody recite the definition of managerial economics? What is managerial economics? This is a science that integrates economic theory, which includes micro and macroeconomics, and decision sciences, which include econometrics and decision-making techniques to solving managerial problems optimally. So optimization or calculus is something that is inevitable. So whenever you're dealing with optimization, you need to know how to find the functions. You need to know how to do what? Differentiate and equate to 0. So step 1, find that function. Step 2, you need to differentiate. Step 3, equate to 0. So whenever we're equating to 0, I had a question last week, when do we know when to maximize and when to minimize? So costs are usually minimized, revenues are maximized, profits are maximized. So I'm going to start with non-calculus calculations, then we'll go to some calculus calculations, then I'll combine that with some other topics. So you'll be given, so we've talked about profit. To say profit is simply the difference between what? Total revenue minus what? Our total cost. So whatever we make is called a profit. So with the functions that I've given you so far, I need you to help me fill in this table here. I'm given output 1, 2, 3, 4, 6, 10. Then you're given the price, 2, 3, 4, 5, 6, 7. Then you are asked to find the total revenue. How do you find the total revenue? You're asked to find marginal revenue. How do you find the marginal revenue? You're asked to find the average revenue. How do we find the average revenue? You're asked to find the total cost. You're also asked to find marginal cost. And finally, find the profit. So you'll be given a total cost function, which is maybe given by 5 plus 2q. So let's fill in this table together. This column, how are we finding the total revenue? From the formulas we're just from discussing.
Quantity times price.
Yes, the quantity times the price. So when you multiply price times quantity, what are we having here? 2. 6.
12,
12,
20,
20,
36, 70.
70. Oh no. Instead of
How do we find the marginal revenue? It's a change in the total revenue. Who remembers the formula? How do we find the marginal revenue? Change in what?
Total revenue over change in quantity.
Excellent. Change in total revenue by change in quantity. So the first one is a dash because we don't have a pair. It's 2 minus what we don't know, 1 minus what we don't know. So we start from 6 minus 2, 4, divided by 2 minus 1 is 1. So what is our marginal revenue here? We get a 4. Then here, 6 minus 12 minus 6 is 6. 3 minus 1 is 1. So what do we get here? 6. Then here, what is our marginal revenue here?
It's 20 minus 12 over 4 minus 2.
Which is 8.
8.
Here,
Eight.
36 minus 20, which is 16, over 6 minus 4, which is 2. So we still get 8 here. Then here, 70 minus 36. How do we get?
34.
Divided by 1.
30 over 4.
8 point what?
8.5.
Great. Anyone behind at this point? Are we together?
Yes, we are together.
All right. So now we want to go to the average revenue. Our average revenue, who remembers the formula for average revenue?
Total revenue divided by quantity.
Total revenue divided by quantity. So we're getting our total revenue here divided by 1 is 2. 6 divided by 2 is 3. This is 4. This is 5. This is 6. This is 7. You'll notice that for average revenue, especially for a perfectly competitive market, the price is the same as the average revenue. The price is the same as the average revenue. Okay. So now let's go to finding our total cost function. So we've been given a function there. So let's fill in that. Suppose here we had 3. So how do we get the total cost function? So here we substitute the Q here. If you put a 1 there, we're going to have a 2. 2 plus 3, getting a 5. Then here what we have? We put a 3 there. 3 times 2 is 6. 6 plus 3, we get a 9. What are we having here? 8. 8 plus 3. 11.
Sorry. Call it that's 3 plus 2Q, right? So if you put 2, that gives 4 plus 3, which is 7, and not 9.
Okay. Let's start afresh. So we're substituting the figures that are there. I think we're erroneously putting, don't put the price. We're putting these on 1, 2, 3, up 10. So when you put a 1, that's 1 times 2, which is 2. So here we get a 5. Then we put a 2 here. 2 times 2 is 4. 4 plus 3, 7. Then we put a 3. This is 6. 6 plus 3, 9. Then we put a 4 there. 8. 8 plus 3, 11.
11.
Okay. 15 and 15. Okay, so at this point, we can also identify our marginal cost. Marginal cost is a change in total cost divided by a change in quantity. So what are we having here?
Excuse me, Colin. On the last one, the one that is 15 there on total cost.
Mhm.
If 2 by 10, it will come to 20. So plus 3 to be 23.
Well, the numbers are here. So if you put a 4, no, let's start from 6. I'm not even the last. Put a 6 there.
Yes,
6 by 2 is 12.
that is 12. Plus 15.
Then put a 10 there. 20. 20 plus 3. 23. Thank you for that. Okay, so I manipulated the figures here. So now let's find the marginal cost. So it's a difference. 7 minus 5 is a 2, and the difference there is a 1. So we're going to have a what? A 2. 9 minus 7 is 2. 3 minus 1 is a 1. So here we're going to get a 2. The 9 minus 11 minus 9, what do we get?
2.
And the difference there is a 1, so we still have a 2 there. Then here 15 minus 11, what do we get?
4.
4. And the difference here, 6 minus 4,
2.
we're getting a 2. Then here 23 minus 15,
8.
8 divided by 4, we get a 2.
Two.
All right, so how do we get the profit?
Total revenue minus
Total
total.
revenue minus total cost.
Total revenue minus the total cost. So let's go to our total revenue. 2 minus 5, what do we get?
3.
Then 6
Negative.
minus 7,
Negative 1.
4 minus 9,
3.
3. And 20 minus 11,
9.
9. Then 36 minus 15,
21, I think.
then 70 minus 23,
47.
47. So using this diagram or this table here, at what point is the firm economical? When can we not produce? How many units should we start producing?
3 units.
So above 3 units, we are profitable. All right. Below 3 units, we're into losses. So we're able to tell from this table that the first 2 units are being uneconomical. We can't produce 2 units because they're too few because of the overheads. All right. So we are better off producing above 3 to making a profit. So this profit function here is showing us that we are having excess revenues over costs as follows. Now, we can also use functions to calculate what we have just done. You would be given the price function as 170 minus 5Q, and total cost could be 40 plus 50 Q plus 5Q squared. And we are being asked to calculate the profit, find profit, find the value of profit. Find the profit, part 2, maximize profit and revenue. Maximize profit and revenue. Who remembers how do we find the profit function? What's the formula for profit? Profit is equal to what? Total revenue minus
Total cost.
total cost. Always remember, if you're given a function of the revenue, put it in brackets. And how do we find the total revenue? Total revenue is given by what?
Price times quantity.
Price times quantity.
Price times quantity. We have the price there.
Yeah. Oh,
Yes.
Yes.
170 minus 5Q. And the Q you're never given, you just impute it. So when you put a Q at the far end there, what becomes our function for the total revenue? 170Q minus what?
5Q squared.
5Q squared, correct. So we're just using the formula that we were given. Our total revenue is 170 minus 5Q squared. At this point, anyone behind before I proceed? Anyone lost? We're okay? Is somebody talking? I can't hear you. I just said somebody was talking about the table. You didn't get it from the table. Is that Clive? Can I proceed?
yes, you can.
All right. So there are those of you who have been in my BID classes. I think you have resurrected quite much better than those that are meeting for the first time. So we call them brought in dead. So those that are brought in dead are literally blank. By the time I'm done, I need at least some people to be in BID. No, in ICU. Right, so we have 170Q minus 5Q squared. So this is on the total revenue. And the total cost already given as what? 40 plus 550Q plus 5Q squared. So what does this negative do? Chavala, what do we do at this point? Yes, Chavala. This negative negates everything here. So we're going to have minus 40 minus 50Q minus what? 5Q squared. Then what do we do next?
Like terms together.
So 170 will be liked with which one?
50Q.
50Q. Then minus 5Q squared will be with
The 5Q squared again.
5Q squared again. Then which one remains alone?
40.
minus. So what becomes our final answer?
120 Q minus 10 Q squared minus 40.
120 Q minus what?
Minus 10 Q squared
Q squared
minus 40.
minus 40. At this point, I'll ask for questions. Is anyone behind?
I have a question. Hello?
Yes, please. The question? Any question? Are we together?
I have a question.
There are no questions. All right.
Hello?
So now we go to finding or maximizing profit. I said anything equated to 0, if it's differentiated, we can say we are maximizing or minimizing. Okay, so how do we maximize our profit? We differentiate the profit function and equate it to 0. How do we maximize revenue? We differentiate the revenue function and equate to 0. So this process of differentiating and equating to 0 is called what? Optimization. To optimize is to find the best value of the output that will maximize or give you the highest revenue or the profits. So step 1, find that function. So we're starting with what? The profit. Find that function. What was our profit function? Profit was equal to what? I, which is denotes the profit, is equal to 120. 120Q minus 10Q squared minus 40. What was the second step? Step 2, we said do what?
Differentiate.
Equate to 0.
Differentiate, yes. So how do you differentiate that?
The pi over the Q is equal to
Is equal to
120
20
minus 20Q.
Correct. All right. Then after we differentiate it, what do we do?
Equate to 0.
Yeah. By now, I should hope every master student here should know how to differentiate. Okay, it is almost exam period. There's no one who should not know. That's a prerequisite. If you haven't learned, please get my videos on calculus so you go through. So 120 minus 20Q is equal to 0. So we're solving for what? For Q. So when this one goes inside, what are we going to have? 120 is equal to 20Q. So meaning what do we get as our Q? We divide both sides by what?
By 20.
20. So this makes our Q to be what?
6.
It should be 6. So whenever they ask you, find the output that maximizes profit. So you're saying 6 units to maximize profit. Anyone behind? Please speak now.
I have a question.
Or forever hold your peace. Yes, Melika.
How did we find the 20Q? On 120 minus 20Q.
Appreciate 120Q is 120. 10Q squared multiply 2 times 20 is 20. Subtract 1 from there. Then what happens to the 4? It drops out because it's a constant. Okay.
Oh, okay. Thanks.
So this is how our marginal profit was 120 minus 22. Any other questions? Okay. Let's optimize or maximize revenue. Step 1, our total revenue was what? 170Q minus 5Q squared. Can you lead me through? Step 2.
Differentiate.
Differentiate. So MR therefore is equal to what? DTR over DQ. So what becomes our MR?
$170 minus 5Q.
So
Minus 10Q.
170 minus 10Q. Remember, our price was initially how much? Price was 170 minus what? 5Q. Those of you who are lazy at differentiating, let me teach you a shortcut or a quicker way, which is acceptable in economics. When you just multiply this number here by 2, it becomes marginal revenue. So 170, if you leave it as it is, then multiply the 5 times 2, becomes a 10. This is what we call our marginal revenue. So if we had 8 here, it would have been what? 16 here. Okay. Then step 3, what do we do? Becky, B.
We equate to 0.
Equal to 0. So what do we get? We solve for what?
For Q.
So if 10Q is equal to 170, what becomes our Q?
Q
7.
becomes 17.
117. So our output that maximizes revenue is what? 17. If they ask you for the price that maximizes revenue, you substitute this price in there and you find your price as 85. So this is what we call optimization. Are we together? Any questions before I proceed? Any questions at this point before I proceed?
Colin, sorry to take you back. I'm new, so I wanted to understand the the first part for optimizing, when we're finding for coding.
I didn't hear your question. Can you repeat? Repeat your question. Is it my network or her network? Can you hear me clearly?
Yes, we can.
Must be her network.
Can you hear me?
Okay, you can try. You can ask again.
Hello?
Yes, we can get it. We are working. Okay, whilst she's stabilizing her network, anyone else with a question?
I have a question.
Huh?
So does it matter? Capital Q, small q, same thing?
The same thing, yeah. The same thing. Any other question?
Can you hear me now?
We'll try to.
Okay, so my question was, when we're optimizing on the first part, when we're finding for Q and we found that it was 6 units,
Yes.
what were we optimizing? That's the question. I don't know if the question is making sense.
Okay. So here when you find, to optimize, first of all, is to what? Is to find the best output that maximize revenue. So sometimes the examiner will be very direct. We'll say find the price and quantity that will maximize what? The profit. So we found our quantity as 6. So we need to also find our price. So we can only find the price by substituting the quantity that we found, which was 6, in the price function, which gives us 140. So the term optimize is general. It may mean to maximize revenue, to maximize profit, or to minimize costs. So here, the question was asking us to maximize revenue, maximize profit. So we started with the maximizing profit. So to maximize profit, we found our output, which was 6. So further on, we would want to also find the price, which is 140. Also, the examiner will now ask you now to find the value of the profit. The profit value will therefore be, after you find the output, you now substitute it. The value of the profit will therefore be 120, where there will be a Q, we'll put the 6. So to find the actual monetary value of the profit instead of the function. I hope I've answered your question and even more.
Yes, you have. Thank you.
Right. Any other questions? Okay, so I have 30 minutes with you. Can I start a new topic quickly? Especially for the new guys, you have missed quite a lot. I'm in Lusaka, so we finished a whole syllabus in quantitative and managerial economics. So just for those of you who, before I leave tomorrow, I'll just look at market structures quickly, which is very interlinked to elasticity. So market structure, lesson 5, looks at 4 key markets that you need to know. So a market is simply a trading place where goods and services are exchanged. So we have what we call the perfect competition, the monopoly, oligopoly, and monopolist. When we're dealing with a perfectly competitive market, we are looking at the characteristics that make up a perfectly competitive market. So whenever we're looking at the market structures, we need to look at it in terms of buyers, type of elasticities, the type of goods that we have, how perfect or imperfect information is, how the graph is, and what profits they make in the short run or the long run. So I will allow my very good students and by taking us the characteristics of these market structures. So let's start with perfectly competitive market. What are the characteristics of the perfectly competitive market? Yes. Number one.
Easy entry.
Yes, there's easy entry and exit. So meaning any participant can enter at whatever time they feel like and leave the market structure. This kind of market structure has what we call identical goods. These goods are homogeneous. There's no product differentiation. So as you're looking at the perfectly competitive market, you're looking at a common market like Sokone, where you have agricultural products. The goods are identical. They're the same. They're homogeneous. There's perfect information. Everyone is well informed that how much and what quantities are available on the market. When there's tomato, people are aware how much tomato must cost. So there's perfect information, and as such, elasticity is high. That's why it's called a perfectly elastic or perfect competition. Elasticity is perfectly elastic. And so in this market structure, the buyers and sellers make what are called normal profits in the short run and economic profit in the long run. They are called price takers because they take the prevailing price that is in the market. So the invisible forces of demand and supply predetermine what price must prevail. So you and I in this market have no influence on the prices that will be prevailing. Neither does government have any control over the pricing that is in this market structure. So examples are, as I have mentioned, so they are easy, there are no consumer preferences, the goods are homogeneous, the firms are maximize profit, especially in the short run. Okay, I've talked about all that. So when we go to a monopoly, you can use this summary table. When we go to a monopoly, there's one major seller who has control over pricing. He is a pricer. And here, there is restricted entry. There are no close substitute because the good is unique. The demand is usually downsloping and very elastic. Information here is imperfect. And as such, these firms make abnormal profits in the short run. And these are heavily regulated by government. And they have very high pricing power. And as such, they're called price setters. Now, as scenario in Zambia would portions one of the monopolies. Of course, in a realistic perspective, we don't have a perfectly monopolistic market. Government has to intervene to some extent. Otherwise, it could be what is called price discrimination. Price discrimination is simply the art of charging different prices for a particular product at different prices. We also have what is called a monopolistic market structure. Here we look at restaurants and retail stores. The structure is heavily characterized by what is called product differentiation. There's easy entry, the demand curve is downsloping, and it's quite elastic, and there are many small firms where SMEs fall in. Demand is quite elastic, they make normal profits, and there's minimum government intervention. And because of the packaging and price and product advertising, they have lead to, or to some extent, medium price decisions. Examples like Colgate Palmolive, where they make their Colgate toothpaste, and there's Aqua, they differentiate their products. So they have some pricing power to differentiate the prices from the others because of how much they put in the ingredients, the fumes, and how they differentiate their products. and we use a term called heterogeneous. When we look at the oligopolistic market structure, we look at the cartel, where firms merge to form what is called a collision, and these firms are interdependent at the kink. They make decisions that are interdependent, connecting that the decisions and the pricing decisions they make should be as agreed upon. Otherwise, whoever decides to charge higher will be let loose. Whoever charges below them, they will go far below to put them off the market. So these ones are unregulated. They are highly elastic and highly inelastic because of the kink shift. Examples are automobile, telephone companies, oil producing companies. And now, because of this oligopolistic market, you have Russia determining how people must pay for their fuel, because Russia is one of the market leaders when it comes to oil. They may decide to whom, on what quantity it must be produced, because of the power that these in such markets decide to fall in. So we're going to do a quick can you remember, where I'll ask you to give me the characteristics of each of these market structures. But before I go there, I'll simply take you through the graphical outlook of these market structures. So the perfectly competitive market, we say the price is the same as the marginal revenue, it's the same as the average revenue. You can see our average variable costs and our marginal costs cut half of the average total cost here. The point where marginal cost and the marginal revenue meet is what we call the profit maximizing point. So when the curve is like this, it's making what are called economic profits. When this goes a little bit down, they make what are called normal profits. But if it goes above with costs, it makes what we call economic losses. So this total cost or average total cost curve is what determines. If it goes slightly down, we're going to have the normal profit. If it sits right here, it's making economic profits. If it goes high above, it makes what are called economic losses. So I usually give examples of women selling perfumes or handbags. In the short run, they'll make or enjoy their profits until it is saturated where everyone wants to sell handbags. They'll reach a point where they'll only make economic profits. Further to which, when people saturate this market, they'll start making losses. So you need to shut down. That's what is called a shutdown rule, where your average total costs meet the marginal revenue shut down. Then we also talked about the monopoly whose demand is downsloping. The point where marginal cost meets the marginal revenue is called the profit maximizing point. So when you draw this area here, this is the abnormal profit that they make in the short run. When we go to the monopolistic market, these are the graphs that look like. So they slant depending on the short run or the long run curves. Then the kink looks like this. For firms in an oligopoly or duopoly, they have demand curves that look like that. So there's what we call a kink. This kink is a marginal revenue gap where firms will agree since decisions are interdependent. So if firm A, B, and C decide to charge 5 watts, and firm A goes up, they'll leave him. Firm A goes below them, they'll go far below them to put him off the market. So this is the reason why oligopolistic markets have a very funny tendency. So the questions that go with the market structures, I have sent them on the group. Those of you who joined the group, questions and solutions are there. So I will now ask for questions if there are any. All right, and let me ask the questions. So number one, there are 4 market structures that we've looked at. We have what we call the perfect competitive market, the monopoly, the monopolist, and the oligopoly. Give me the characteristics that we have in the perfectly competitive market. List 5. Number 1. At least I can see the names there, so I'll follow the names I can see. So we start with Kauma, Becky, B, Carol, and Chilenga. Perfect competitive market. Tell me anything.
It's homogeneous.
Easy entry
Mm-hmm.
and exit.
Okay, I hope that's on point. Yes.
It has influence over price.
They have influence.
Goods identical.
Goods identical. You have 1 minute to exhaust whatever you can. I'll give you marks collectively, then I'll go to the next group. So say all your points, the names I've mentioned down.
Pricing is the same.
We're listening. I have 30 seconds to go.
No consumer preference.
Mm-hmm. We're listening.
It has no influence over price.
Okay. All right, if that's all you have to say, I'll go to the next group. DC, Dora, Chinyanta, Fides, and Francis. Give me the characteristics of a monopoly within a minute. I'll grade you afterwards. As many points as you can.
Very difficult entry.
Mm-hmm.
There's one major seller with control of price.
Okay.
It is highly
Inelastic.
elastic.
Highly elastic. Mm-hmm. Highly.
It is also heavily regulated by the government.
Okay.
Did
It's
you
a
say
price
about
setter.
it? Okay.
Mm-hmm. Ten seconds to go.
One large firm.
Okay.
No close substitutes.
Yeah, and the products are unique.
2 seconds. Okay, we go to the next group. Monopolist. Gillian, Inotu, Maluba, Mary, and Masapi. Within a minute, give me the points for Monopolist.
The demand curve is downsloping and it is highly elastic in the long run.
There's an easy entry, and there are many small and medium firms.
Mm-hmm.
They also make normal profit.
Mm-hmm.
There's minimum government intervention.